Hello.
Mhm.
Guys, wait for us some time. We are starting the session soon. Okay, please don't leave. And we are just waiting for some student. Okay, after that we will start the session.
Yeah, sure.
Yeah, sure. So guys, good morning. Thanks for being on time. Welcoming to the hackathon events. Okay, so I am Pratiksha Thaure. I am from Sedlan, and today you guys have a hackathon event, and Mr. Sharat Kumar Gilla he will take the session. So he has a more than 5+ year of industrial experience. Okay, in IT sector only. First, he worked as an analyst associate team lead in Global Logic Technology. Okay, and after that he worked as After that he worked as an analyst software engineer in Capgemini, and right now he's working as a machine learning engineer in Predera Technologist. Okay, so he has a more than a 5+ year of experience in this field. So like whatever you have a doubt regarding the course, what is the data analytics or the data science, okay, anything regarding to the how can you guys make the project, so you can ask to the Sharad and you can clarify your all the doubts. Okay, guys. So please don't shy, and session it should have to be interactive, one to one type session. Okay, so then only it will get interest to for him also as well as for you guys. Or else what is happening, he's explaining and you guys are not asking any kind of question. This is not happening in this type of session. Okay, you should have to be interactive. You can ask question to the Sharad also. Okay, what kind of project you need to make while doing a project, what kind of difficulties you are facing, how to overcome that difficulties. Okay, how to become as a data analytics, how to become as a data scientist, whatever will be the field, please ask to the Sharad. Okay, guys, and within some time, within 1 or 2 seconds, minutes, we are starting the session. You know what this Sedura, right? Sedura is nothing but the IT company, and Sedlan is nothing but our company product. So in this Sedlan, so we are training the students in a different courses, just like data analytics, data scientists, okay, Power BI, AI, all the courses we are training in that. Okay, so like being an IT company, you will getting the project based learning only. So you are learning, and after some days, at the end of the month, you guys will do the practice of the project, and that is nothing but the live project. Okay, so like right now, whatever you are learning, on the basis of that, you can ask question to the Sharad. Okay, whatever right now you are learning, you are in the middle of the course, somebody at the starting, they have completed 1 or 2 sessions, something like that. Tools also, so whatever you are getting the doubts, on the basis of that you can ask to the Sharad, as well as like you can ask his like a real time experience. Okay, how he become as a data scientist, how become as a machine learning engineer, how he's become as work as a data analytics. Okay, he has a very good experience in this field, so you can ask to him and clarify your all the doubts. Thank you, guys. Guys, if your friends they have not joined the session, please call to them and say to them ki like session we already started, please join as soon as possible, because already it's been like 18 minutes we have led the session. Okay, so please try to please say to your friend to join as soon as possible. Yeah, thank you. Um, Guys, we have started the session. Please enjoy the session. And Mr. Sharad Kumar, he will take the session. If you have any doubt, please ask to the Sharad. Okay. Have a great day. Enjoy the session. Thank you.
Good morning, everyone. Very good morning. So, uh, I'm Sharath. I have an initial experience of total of 4.5 years now. So, I'm working in data field around like close to 3 years. I'm working in Credera Technologies as machine learning engineers from last 2 years. So, there I worked in like multiple cross functional testing. So, I joined as data analyst there. I was part of two projects where data analysis work was done. Later, I was into machine learning projects where we the client was Walmart, where we developed a solution for demand forecasting, which predicts the sales and inventory management. So later, currently we are working. I'm working on the revolution in ML. I can say Gen AI. So we are developing generative AI solutions for our product and as well as the clients as well. So this is a brief about me. So coming to this session, I think you have like heard many sessions like say, such a passion. So what you are expecting from this session? Like what do you want to learn? Anyone? You are not sitting here for something, right? You are expecting something.
I'd like to know more about the experience.
Okay.
Yeah. I would like to know how
The real time scenarios.
yeah, real time scenarios and real time problems, how we can handle if we get it.
Okay. I think you have done many projects and many tasks, etc. I guess. So most of like all the time, I guess you are working on CSV data. Is it always it is CSV data? So in real time, we don't use CSV data. I can say it is not easy to transport. It is not easy to stream across the clients and all. Most of the time, the data will be in JSON format or JSON format. We should be like we should know how to deal with it. Like data is not always clean. What you see in the Kaggle or whatever it is. It is not at all CSV. It is not at all clean as you see. So we'll be getting raw data set. Like we'll be getting most of the data set from the engineers, like data engineers. So they will be preparing data streaming pipelines. So where they collect data from different sources. It might be structured data set, it might be unstructured data sets, whatever. So they do the transformation and they dump it to our server, our end in our database. So where we need to connect it from there and we need to do all the pre-processing steps where data science team, where data modeling team can use it for the further modeling. So here in the life cycle of a product, if you are giving a data science or a machine learning product, so most of the time spent will be on data cleaning and setting up the data, I can say. So 70% of the time will be cleaning and transforming the data. So rest we can do the modeling and all. It is another other scenario. So here when we are dealing this data, like in my real time experience also, like we'll be getting a lot of data which is very much unclean, like it is not at all nowhere clean. And we are using standard techniques like what is the case when you are getting null values, what will be your approach? Let's say we are having a data of 40 columns with 10,000 rows. So I'm having at least 20% of missing columns in three features. So what will be your approach? Sorry? With average. Yeah, but in real time, we should not tamper the data. We are not allowed to fill it. We should deal it. Sorry.
Should we drop it?
No. Again, and here the big scenario is always dealing with the data comes with the domain knowledge.
Yeah. Missing on the columns or
Yeah, whatever.
Yeah.
Based on the columns or whatever it is, like it's not always your final call to impute by the things what you know. But it generally depends on the domain data. So let's say, for example, I'm having a medical data where I'm collecting data from patients. So there a column is gender. So in that, out of 100%, 70% is filled with male and female, and then 30% is not filled. So what will be the approach in this case? So it's not always to drop the records because we are dropping the records of the patients. So depends on the domain. So let's take a case of lead scoring. Like you want aware of lead scoring. Okay, I'm having a website. Let's say it's a real estate website. So I'm having a traffic, like people are coming and looking at my website, and few people are interested to know. Few people are taking filling the form, what I'm giving number, mobile number, email ID. Few people are taking my mobile number to call across, or few people are going through the website and all. So the traffic what I'm getting for my website is called as leads, but not all leads are going to take my product. So I can't call each and everyone. So right, actually, if I want to follow up each and everyone, it takes forever to call everyone. So we don't know if they are potential leads or. So here the scenario is we will be training the model whether the customer who is showing interest based on the data what he felt, based on the time he spent, based on the resource or based on the channel what he got to know about our thing, and we can filter it. So in this case, if few people are not providing their mobile numbers, we can drop it. So because they are not potential leads. But in case of medical data, we cannot drop the records because it's a patient data. We need to do some processing for that, and we need analysis. Like it's not a record that we can ignore because they are genuine patients, and we need to tackle this. So there, mostly we'll be introducing a new column, NaN. So instead of imputing with any other male or female, it will be like a third column NaN or something at least. Like they don't want to know, but the data what they are provided is genuine actually. So we can get answers from them. So this is one of the real situation where we had to work with Dynamics, like one of the client. There we will be getting medical records as well. And yeah, just I mentioned example lead scoring. So there we can filter based on the data what we are getting. So when Client approached us. The data what we had is like 600 columns with 8 lakh rows. So we cannot train a model with 600 rows. It will take like days to train. So here the main situation is to clean the data.
So, and about like one doubt.
Yep.
The blank spaces. There's like have some doubt in my mind. Like, can we fill it with null or not?
Depends on domain actually. That's what I'm going to
That's fine.
So if it is like medical data, just I give an example. It's not always the same, but if it is medical data, you can't predict and fill it is male or female.
Yeah.
So instead we'll be putting nan or they don't want to. It's a third column, like we can say. So if at all the new record is coming, it will be either of these three. No fourth column is possible here. So there was a situation where we had 600 plus columns and some 80 lakhs rows records. So in these 600 columns, we can't utilize everything to train a model. So here the cleaning process is very hectic actually. So and the records what we had is not straightforward. So for the records what we have a other Excel sheet where they provided the map. Starts from ethnicity, starts from religious, starts from location, whatever it is, they are having a code word AT, FT, something which is related to some other. So we need to take a reference from the Excel and we need to do this mapping for all the data. So that is the task. And again, as you mentioned, there are many null. So they don't mention any mapping to null. And always we can't blindly fill null for everything. If it is categorical, if it is float, if it is integer, we don't. So that was the scenario. So like it took a lot of time to clean up the data. And just a small, I'm just asking a small guess, like what do you think would be the final data set I was having after cleaning all the 600 columns? Like what will be the final columns I would have? Just small guess. Yeah, 600 columns were the raw data. But as I mentioned, there were not filled completely. I need to do cleaning, and not every column is genuine. Like not every column is important for us in the model. So based on the domain knowledge, we need to take a call. Based on the client's input, we need to take a call. So what would be the rough number? Like what I left?
500 probably.
600 column. Okay, 500. Next, any guess?
Prepare on 100 columns.
So the final model what I built was with 40 columns.
40 columns.
Just 40 columns. So and we also compared like we had columns of 250 after cleaning. So when I'm building a model with 250 columns and when I'm building the model with 40 columns, there was not much difference. So what is the conclusion here? Like what? Like why only 40 columns is giving the same accuracy and same metrics? Why 250 columns giving the same metrics and same accuracy?
It depends, the data is same for the columns are same for every data, right? So if we take a subset of the data also, it should generate the same output. And if you take the whole as
I'm talking about the features, not the rows.
features. Okay.
250 features, 250 columns and 40 columns, not rows. So here, like as I just mentioned, every column is having a separate, like, particular weightage to give the predictions. So based on the domain knowledge, people who are coming and people who are showing interest, they don't backstep to fill in their details, just like mobile number or email ID. So these are the main important things for any of the firm to contact with. So those are the main two features which show the importance, like which are having the much weightage on the final output. So yeah, there are many columns which like having a very least weightage. They're not important for that model. They're not important for the current model to rate. Like when we are getting the accurate results with 40 columns, it's not good idea to have 250 columns to run the model for longer hours. So like this was a basic idea what I dealt with. Like 600 rows is nothing but the responses from the website. They will be giving the JSON response. So what the page is holding, what or the entire website is holding. So that we need to clean, that we need to transform, analyze, and see what is happening.
Maybe we
And
can transform the JSON file format of the data, like
NumPy pandas, like
libraries.
yeah, you should go through. The only funda here, like the main point, what I'm trying to say is not always we are getting CSV data. Data can be any form.
Any format.
Can be JSON, can be JSONL, it can be image processing, can be text, whatever. It can be anything. And what are the basic things you guys do when you got the data to clean? So what are the main things to focus? What will be the approach? If I'm giving a data set, what will be your approach?
Look into the data first and look whether column to row, like is it the data is completely filled or not.
Okay.
And looking whether the data is correct in, like, someone can place on an in place field and someone can place something else.
Quality of data.
Okay. And
Quality describe and then information and then it comes from a language are there. And then we see how many outliers are there. And by seeing all these, we will visualize the data by filling all those.
So what are outliers? Anyone?
Data which does not belong to the
Example?
for example, like the total class got marks like 10 to 80, and someone got a mark like 90. So 90 is like
Like you got like, have you heard about anomaly? Anomalies in data? No. What are the difference between anomalies and outliers? Anyone? Any try? It's okay if it is wrong. Okay, as you mentioned, outlier is not a wrong negative. So let's say there is a column age. Age starts from 0 to 100, but you can't enter 0 or 1 or 2, like, are you getting? So it is an outlier, not an error, but it's a valid to have age between 0 to 100. So what if some human error and it got like age value is like 247? Then what it is? It's an anomaly, not outlier. As you mentioned, 94, 95 age, it's an outlier. When every record is having around, like, it's like an insurance client, for example, it's an insurance data set. So insurance data set, like, they will give you insurance based on your health conditions and also your financial thing. So they're not ready to give insurance for a person who is having 95 age. And it's not an error, it's an outlier. So if the age is 240, 250, it's an anomaly. It's not a valid record.
based on the column, we got it as
Exactly. Based on the column, it changes. So there is a difference between outlier and anomalies. And like, what is the approach? Like, what will you do with outliers?
we'll fill that or we'll remove them.
Okay.
Yeah, fill it with send formula. So we'll fill it with the outliers will be
Outliers, like, why filling outliers? I didn't get it. So null values you will fill. I'm talking about the outlier. Let's say there are records, as you mentioned, the students score and all. So if everyone is ranging in between 0 to 60, and there are two records who are having 85 and 86, are these outliers?
Yes, yes.
Why? So it's not an hard fast and rule that no one should get 85 marks out of 100. Are you getting? So data is spread across. So with this, our analysis will be affected, but it is not an outlier because nowhere it is mentioned that it is a cutoff. It should not cross there. So it is inside the limit. If 0 to 100 are the marks, 85 is not a big deal. If it is like 105 or 106, then we need to think twice. So again, what I'm trying to say is everything depends on the domain knowledge and how we understand the data. It's not about the numbers which are higher or lower. So what it is trying to explain in that entire scenario. And what's like anything more on outliers, like how will you treat in your learning? Did you come across any outliers where you are in confusion to remove it or not? Like is it outlier or not?
Yeah, by calculating, we will know which one outlier. So we gradually, usually remove that out.
Yeah, but this is the main thing here. It will affect the model, it will affect the analysis, but it's not an outlier. Like you should really justify if you are removing a record. So as she mentioned, 85 should be removed. Like why it is in the limit, so we should not remove. So yeah, when we are facing with the clients, we are not allowed to tamper with data. We are not supposed to remove any records. We are not supposed to impute records on our own. So instead, we can use nan or null or anything nullify that, but we should not impute based on our knowledge. So that is the main catch here. And so, what is the end goal of the data analysis? What you are doing from long?
And goal of the
Yeah, like why do you analyze the data?
uh, we analyze only the past data for data analysis.
Okay.
So we give the pattern like how the product was sold in the past 2 months or periods. So it depends on that. We can make some changes and uh, we develop a product to go for better, like we can offer something to the client.
Like what is EDA?
Exploratory data analysis.
So what you are doing exactly there? What are we supposed to do? And what is the end goal of this EDA procedure? Anyone?
Visualize the data.
And so what is the end goal of doing all these things?
By basing on the domain or by retrieving provide a solution by visualizing the data.
Visualizing data, we can't provide solution. So here itself it says exploratory data analysis. We are exploring the data, what it is telling us. We are seeing if it is a valid data. As you just mentioned, we'll be checking for the quality. In the place of name, we can't give the age. In age, we can't give name. So this quality check. And we are seeing what it is trying to explain us, like how it is diversified, how it is spread across the records, how it is spread, and what can we analyze with the data. So let's say if I'm having a data of 10,000 rows, in 3 columns, I'm having the same entry. Let's say take age. Every age is like 24. So what is the point of having that data? So what my model learns with the data. Are you getting? So that's what like we are exploring and we are analyzing if it is a valid data, like how it is spread. Is it spread correctly or not? If it is classified, like if it is by classification thing or it's a continuous variable or what it is trying to say. So then we'll clean the data for next step. If we are doing any predictive modeling, so that the level of clean data will give the better output. Have built many models. The main challenge of building models is the data set. Even if we are having 80,000, 90,000 records, it doesn't matter. If it is not clean, if it is not a quality data. So any model, anytime, like how many times if you run the model or different algorithms, if you run, you'll be end up getting 50, 60 accuracy. So it doesn't is a big deal breaker for the client. So we need to show the client like what is the output, what you are trying to deliver them with that. So why he should actually opt the data science in his field. So with this data analysis, we can get many insights. You can point out, let's say in a student in a class, always from last 4 to 5 years, always maths in maths they are getting good score always, irrespective to anything. So what is the insight here? Is the teacher who is teaching maths is a good fit to teach them in a good way so that everyone are getting always highest marks. This is one of the insight what you are showing with the visualization. You're not just visualizing or anything. So, and visualization and showing things to people means when you are dealing with a client, when client is talking to you, so it's not always the technical person who is dealing with you. They will be managers and they will be BS business analysts who are not aware of technicalities, but they know the output, they know the goal. So I want this. So this is the thing. This is the thing. Like, what is your take on that? So you need to like this visualization help there. So this was the analysis. So when this happened, this is the thing. When this happened, this is the output. So here you are having the least values. Here you are having the highest values. Here you are lagging. So the data is diversified in this way. So the data is having these many columns. The data we can use these columns for modeling. So these are not useful. So this is the spread of the data what you provided to us. So with this data we can deal with this. So instead of showing the numbers, we can show it in a graphical representation so that they'll understand quickly instead of going deeper into the technicalities. So the like what I feel it's not always the same. Like what according to me, the output of this exploratory data analysis, we'll learn about the data. Like then we can make machine learn. So we can give a good model of what we learn. So we know what columns are suitable. We know what columns is having a genuine data or correct spread of data, and we can train the model. We can directly can't blindly train the model without analysis. So here the data analysis is important. As just I mentioned, with 40 columns, I'm getting the same output. With 250 columns also, I'm getting the same output. So here the 40 columns are the most like having the most feature importance for the output of the model. So even if I'm getting the other columns other than 40, it doesn't matter to me. If these 40 columns are filled from the new records, like which is test data, which is unseen data, I can get the output easily. So with this, they can have a sense like to whom to approach, the clients whom to approach and whom not to approach instead of wasting time. So here, the data cleaning will be a difficult task. It will take a lot of time. It's like understanding the data before you're modeling and before you are developing an application. So that is the important thing here. And so, what are the difficulties when you are visualizing or dealing about the data? Like when you are doing this EDA, what are the difficulties you feel? So what is the difficult task in this entire process? What do you feel according to you?
When that is like so you should be take to visualize the data, provide some understanding based on the documents.
So, like I just mentioned, it is about insights. Like when you are when you want to visualize, like what you want to visualize actually. Based on that, you choose the columns. If you want to say within this time frame, this is the spread. So based on that, you choose the columns and you perform the visualizations. Any doubts? Anything you want to ask so far? So now you got an idea what is anomaly and what is outlier actually. When to remove the record and when not to remove the record.
We can remove the record when it is an outlier.
Yeah, outlier also you can remove, but it depends on the task and depends on the domain. Not always outliers to be removed. It may it may affect the analysis and it may affect the model class, but it's not always a good practice to remove outliers.
Like, can we remove anomalies? Like,
Yes.
in any case.
So, for example, as I just mentioned about the age, let's take there are 10 records. In each records, the age is like 20, 25, 27, 30, 40, and in one record it is like 247. What will be the mean of that column?
More than the average.
So what is the like how can an average of these age column will be 150, 160? So what will model learn about this? So when a real actual genuine record comes to the model for prediction, so maybe there the record the age will be 23. So here the mean is 160. Like you can see the difference here. So what will model do? Model can't predict the trends between this, and it will give least score. So here, when the data is entering into this modeling thing, you can give any model. It's not that it can't learn 100 or 1000 number. It is not like it will learn everything. So what you are giving, what how it is performed,
Depends on providing the good.
exact quality of the data. So here I have given this task. Yes. Here it is in financial data. So like I think everyone are heard about this fraudulent transactions. Okay, so like what are fraudulent transactions? Like what are the basic things when you heard about this term fraudulent transactions? What is coming into your mind? Like how will you flag it as basic general human being? Like how will you flag it? Like how you say that it is a fraudulent transaction?
Sending money to someone unknown.
He is unknown to you. He is unknown to you. It's not like he is unknown to everyone. Anyone? So no one received any calls regarding this fraudulent transaction, like send me this, you are due this bill and all. No one. Hmm?
So without your consent, the money can be get to them.
Okay. Yeah, as you mentioned, without our consent, money is getting detected, or let's say someone is calling us, a bank person, and saying to cross confirm, please send me the OTP or whatever it is. Like you know what is fraud? Like it is not a genuine, so it's not a thing we can accept. It's a fraudulent. So
So recently, I heard about this scam, like where the AI is trained to call someone with our like friend's voice or for family voice and ask them like to send money.
yeah, that's an interesting field where I was researching generative AI. Like we can give input as text and we can get output as speech, vice versa. Speech to text, text to speech, image to text to image, text to text, and what not everything we can. So here, this is the like new revolution in ML field, generative AI. So there, the architecture and everything is different from what we are having. It's a deep learning based on thing. So there also we are dealing with the data, and now I can say this is a new format of data. So everyone using ChatGPT? No. Okay, when you are chatting with the bot, so the data is stored in a format in a chatting format. So we are having a chat with the GPT where I said hello, it is greeting me. Then I ask my query, then it is giving the query. Then it is end of the session. So the transaction user and assistant makes a record. So this is a new format of record which we need to deal how to train the model. So this is one of the format what you are seeing the traditional thing CSV, JSON, whatever Excel, whatever it is. But this is the ongoing thing. We'll be having messages, we'll be having conversations. That is the record. So we need to process that data. So again, with the help of the Python only, we need to do.
So if like a conversation is generated, so it is recorded as the
Yeah, one record. It's not always the same size as I mentioned. Like, you know, the CSV it is very much structured. We'll be having everything in a line. We can see it in a glance. But here, not always all record is in the same context or same length. And the data storing, the data retrieving also is a difficult task. Not the easy way. Okay, coming to this. There are many like things where we can flag the transaction is fraudulent. So if there is a customer or if there is a situation where from his account money got deducted in midnight 2 or 3 p.m. at a location where he haven't visited. So here the catch is like here what this exploratory data analysis show us is in his history. So that usual transactions of that card or that bank or that person ranges from this time to this time, so and so, and it never crossed this time. It's the first point. It's not always true. It might be an emergency, and the location and the radius, like and the kilometers from where the transaction has been held from the place where he's staying, and the place, like is it what at what place the transaction happened, and the amount of transaction. It's a usual limit what he usually do, or usual transaction. Like, does he have any record of having that amount of transaction in past? It will show if it is in fraudulent transaction. So, and here it is also case sensitive data, I can say. So it's okay not to penalize original transaction, but we should not miss a fraudulent transaction. Am I clear? It's okay to let go of a genuine transaction. Like if we are feeling it's not fraudulent, yeah, we can leave. But in a doubt, we should not let a fraudulent twist. So there, this data plays an important role when we are cleaning and when we are sending it to the model. We should able to capture actual fraudulence, like which means the recall score should be higher. In this case, our main focus is here is the recall in medical data as well. In medical data, let's say we are predicting cancer patients. So the target column is if he is a potential cancer patient, like yes or no. So what if what if the model is predicting a patient who is having actually cancer, but it is predicting as no cancer. We are predicting he is not having cancer. So then doctors won't be treating him. So the vice versa can be done. Like if the person is not having cancer, but the model is predicting as yes, yeah, I can take a few more tests. Then he can come to a conclusion. So it depends on domain, this case sensitivity changes. Here also in fraudulent transaction also, we can't let escape a fraud. So here is the data. So general cleaning things you can do, check for the missing values and see how much percentage of data is missing. Like, like there is this thing where missing values also can play an important role. Let's say if a person is there, like he is ready to give the information as a sort. The person is not ready to give information, which means no entry there. So here itself it shows he is ready or not. So we can classify it as this. Instead of taking the data, we are asking if he is okay to give the data or not. Here itself is a new feature where we can capture instead of taking the data. Yeah, check for the missing values and handle them appropriately, and identify the outliers in the data as just I mentioned. Convert the date column to suitable format, and here date column. So when we are receiving data, it's not always the exact date, or so there are many formats and there are many time zones. So based on the time zone, we need to convert it back and we need to analyze it. And the time column plays an important role in every data. So if we start talking about this time series, it will be a separate I can say not session, separate uh, coaching, like what you are doing this. It will be separate thing. You will be you can deal it with a separate coaching what you are taking, like that. DA is a separate thing for time analysis. Also, you can take separate. Yes, it is that huge. And like most of you know, like we are having this weather predictions and all. So it depends on this time variable. So what like we are having a project where we need to deliver this demand forecasting. So there the time is a main important thing. So where users might ask, like users might want to know the prediction of future 1 year, future 6 months, future 1 week, future 1 hour, 1 day, whatever it is. So we need to prepare data and we need to prepare a model in such a way that it needs to understand the trends in all time zones what we have: yearly, monthly, quarterly, half yearly, daily, and all. So there we need to give a data, impute the data, and create the data in such a way that it will be able to give the predictions of all different time zones. So here, time column plays an important role. And analyze the distribution of transaction amounts over the time. As I just mentioned, the amount over the given time frame. Is it anywhere spiking up? Is it very high when compared to the distribution, or it is normally distributed? Yeah, and you can see the transaction amounts across its merchant categories. Identify the merchants with highest and lowest occurrence of fraud, like in which category most chances of fraudulence can happen. So there is one more flag what we can put. We can have a checklist like in, which merchant, like what type of fraudulent, like let's say it is food or groceries or technology, like any electric items or any clothing items, whatever it is. So we can have a flag there. So investigate if a particular merchant category is more, just as just I mentioned, like who are more fraudulent prone. Analyze the distribution of transactions amount based on the customer age and gender. As I just mentioned, like there are old age people who don't know, they just give up the OTPs and all, end up being getting fraudulent. So for them, if we flag, like if any transaction is going to happen, so we can, like there are many flags what a bank or any server can set up to cross check or to accept to approve if the transaction to go on.
Yeah, that call immediately.
Exactly. So where for whom, like in which areas they should be more. So with this analysis, we can get an idea. So in this area, we are getting more transactions in this age, particularly in this location or in this category, in this merchant thing, in this area. So we can flag that instead of putting everywhere, every flags and every checks, we can stop it.
Can have some criteria.
Yeah, this is a flag checklist where we can actually give more importance, like more prioritizely where we need to set up these things. Investigate if there are any certain demographics associated with high likelihood of fraud. Yeah, I just said who are more fraud prone in that segment. Like what is the important thing where they are becoming fraudulent. Startup analysis based on the card they use and investigate if they are more commonly associated with fraudulent transactions. And then we can also see if they are fraudulent, like if they have a record of fraudulent transaction before. If someone knows that we can easily take money from him, they will approach continuously. If he is not aware, if he is not aware of what is going with his account or what is happening, so it's easy to get fraud. They use advanced relations such as heat maps and violent plots to see the relationships of data. As I mentioned, it is not relevant to have a more number of columns which are not important to the model. So that you can check with the correlation heat map. So we can, if you see that there are two columns which are completely correlated. If this is increasing, this is increasing. If the column A is decreasing, column B is also decreasing. It's not. It is not no point to have both. It's redundant for a model. So the model learning will change and it might overfit because of these same patterns. What it is seeing across the columns, it might. There's a potential chance of overfitting. So to reduce that, to reduce the overall output of the application or the model, we need to clean the data based on the knowledge and based on the analysis what we do.
So my question is like when we can go for like when we are doing the visualization, when we should go for the other maps, like you are telling like heat maps and all that, right? So how can we determine that this data is suitable for this map?
So as I mentioned, what you want to see actually, like from the map. If you want, as I just mentioned, if you want to see the distribution of transactions over a period of time, so what will be the suitable graph there? Distribution. Sorry. You are distributing the data over a period of time.
Over a period of time. Graph.
Yeah, got it. And if you are trying to say these are the like okay, like let's talk about number of transactions. So there are four categories. One is food, one is clothing, one is electrical, one is groceries. So you want to see where more number of transactions are happening. So you got an idea like what you want to. Now in this case, what will be the graph you think of? You have four categories in a column and you have number of transactions and you want to see in which category more number of transactions are happening. Okay, done. Like you also just mentioned, like you don't know what is a suitable graph. You got an idea. So you just see what you want to. It depends on that. You can see.
Use scatter plot. Scatter plot. Scatter plot.
Yeah, you can use a scatter plot, but what scatter plot is explaining in that? Can you visualize? Can you get an insight from the scatter plot? Okay, if you can, it's not a big deal to try and experiment. So once you get an experience, once you get what it is, you can do it. But when you are in confusion, you just check it. So it's not big deal, it's not a sin. So here in this case, you are seeing the number of transactions and all. Yeah, bar graph shows the number of things what is happening. And if you want to see the distribution over a period of time, then distribution plot, just like an example I'm saying. So based on the situation, graph changes and heat map will give the correlations. Like we will be having columns on both axes and it will show how they are related. If there are any graphs which can show the relation, yeah, you can go, you can choose it. Not a big deal. So there we can see the relation and we can easily get an idea like how much these columns are related and is it a good option to keep the column or if it drop the column. Yeah, explore the correlation between the different features and target variable, as I just mentioned, and for the features that may be strong indicators for fraud. So here, the suggestion is like when you are doing this analysis, take the target column and see other columns like as I just mentioned, categories or area or number of transactions, and try to relate the other columns with the fraudulent field, like if it is fraudulent or not. So you can know where fraudulent are more, where genuine transactions are more. So it's a better idea to relate the target column with other columns as well. So you can get an idea how it is related, how it is dependent on other columns, how it is being affected with other columns. Yeah, that is it. And like any time you come across this imbalanced data set,
Load balancing or imbalance.
imbalanced. So let's say I'm having a data set where I'm having 50,000 records. So in the target column, I'm having true classes as 48,000 records and false classes as 2,000 records. So what will happen to the model and what will happen to the analysis when this data is given to you? What can you think of? You got what I'm saying? Is it clear?
We will balance.
This is imbalanced data.
Balance.
Yeah. So when you are fitting a model, when you are splitting the data, whatever it is, so there might be a chances where your trained data will be having false classes and your test data is having only true classes. If there are 48,000 records of true and 2,000 records of false, when we are randomly splitting it, there might be chances of happening this. So this is the imbalanced data set. Like you need to check if the data is balanced or not. So what happens with this imbalanced data?
You cannot predict the right output. You can't get right output. Yeah.
You can't even give the analysis. Even if you are analyzing, if it is a single class, whatever you do is associated with the single class. You can't predict what is happening with the other class. If you don't have any extra, like if you have don't have any sufficient data of that class. So for visualizing, for analyzing if the data is genuine, as I mentioned, on an average on a transactions of 1,000 transactions, how many fraudulent transactions can occur? Just a random guess. On 1,000 transactions, is it genuine data set now, or is it not proper data set? Is it a genuine data set? Because the domain itself is having this scenario. So not 50% will be fraudulent transactions, right? So this is the domain, like it's a genuine data set where the potential chances of fraudulent will be 10 or less than 10, I can say. So for analyzing part, it's fine. Like if it is this case, if it is this domain, if it is this, you can analyze. Like and you can show that there are minimal fraudulent transactions, and in that minimal fraudulent transactions, these are the areas where you need to take care where fraudulent transactions are happening. In an entire big picture of total number of transactions, you can compare it this. Even if it is minimal, the minimal where it is happening, you can narrow down the problem statement. So when you are like going to modeling, when you are going to create a modeling part, then you need to make sure to give a balanced data set for training purpose so that it can understand the trends and can predict the fraudulent or non-fraudulent transactions. If you are giving this such kind of data sets, it all like most of the time it is trending, like it is trending towards the true class because it had learned a lot more of true trends than the false trends. So obviously, what we are teaching, like it will learn based on the data set, and it will end up predicting these true classes most of the time. So there we'll be using some techniques called as oversampling techniques. Yeah, when we are feeding data set to the model, oversampling techniques we use so that we synthetically create number of records based on the false data sets. So the number of records, there are many methods, but generally people use this min-max scalar, standard scalar, and smart analysis for these things. So when you are using this, there are techniques. What happens is like there are a few techniques which will oversample the data and which will create the records, like similar to the records what we have in false class. It will create a new records in the same basis so that it will balance the true class, so that we can have the trends. Proper trend when the model can give the output. So this comes after the cleaning part is done, not now. As I just want to explain. So modeling part, we can't give the imbalance data, which is like 10 and 10% and 90%. Any doubts? Any things you want to ask? Open the doors.
There are null values you mentioned there are 1,000 records. There are null values in specific age column, age column. So there are more than 200 null values. But basing on the domain is an important one. So by dropping the 200 null values, every column will be affected.
Yes.
And then and you said we cannot manipulate the data.
It's not always like based on the domain, based on the client requirement, we can't do this. Let's say we are having a data set where we are having amount paid by client, for suppose amount claimed by the user, who is amount paid by the user or the website. So there are 5,500, 3,300. So there are null values. Like what value can you give there? So we can't create new data there. So if it's an age for modeling and all, so the best thing, like it's not a suggest, like it depends on the domain. So you can take an average, or in some cases you can simply bin the age, 10 to 20, or like middle age, young age, or anything, and you can try to impute with that. It's not always one hard fast rule. So situations comes up and the things changes. It always be the situation like so when you are doing this analysis and all, you might also come across the new situation what you have not dealt with the previous task. So in this current scenario also, we don't know like what we are going to get. Based on the domain knowledge, based on the data understanding, we can suggest this what this can be done. So if it is not affecting the data, if it is not affecting the model, we can go with the approach. Yeah, we can choose the average. It's not.
But what is mean that is what confusing for us. So we are doing the data set that, but we didn't done these methods in the past. So for us, this is a new data. So we feel like okay, what is this? And we feel like confused. So that is what we. So how to handle the data?
Yeah, if the data set, if very little amount of data set is missing, you can drop it. If it is relevant, as you said, if we can't impute any random thing, and if we can't ignore, then drop it. If it is affecting the entire model, so it's dropping few records will be suggested when compared to imputing and creating new data. So what I mentioned when we should not tamper the data is we should not create, as just I mentioned about the amount column. So we are not supposed to add any average column. We don't know what product he is purchasing or what amount he is paying towards the client. That is the case. Any doubts?
No doubts.
Okay. It's already there actually. So here is a normal approach what I have made for the problem statement. Yeah, mouse. Yeah. One thing. Here. So it's not always the approach, like it should be the hard fast and approach. So like it's about you are explaining the analysis what you are providing. If you are giving a plot or if you are giving any like say here I'm giving the df1 dot shape and df2 dot shape, like what I'm trying to see and what I'm trying to achieve and what I'm trying to show. So it's in that way. It's not always fixed that these are the analysis you should perform. These are the comparisons you should perform. These with these columns. No, it's not like that. Like you should understand like what you are trying to show with that analysis. So this is the rough basic thing what I'm doing here, like basic data check. As I mentioned, the number of transactions what I'm trying to see here. And I'm doing some data processing for my analysis. As I just mentioned, I'm pinning the age into groups. It's not always the same. That's what I'm trying to explain. So here I'm seeing the age groups and the number of fraudulent and non-fraudulent transactions where the fraudulent transactions are more. So here our main focus is not about the non-fraudulent transactions. Here our main focus is to catch fraudulent transactions. So here we can see the number of fraudulent transactions happening in different age groups. And you can see who are the targeted victims of frauds in age groups. Yeah, these are the area-wise fraudulent and non-fraudulent transactions. So different job groups of the data set what I'm having. So I'm just seeing the quantiles in the amount, the box plot of the amount. As you can see, there is a lot of difference here. The most of the data lies under here, and a very little amount of the data is there. Like you can point out why it is here, like what sector it is here, in what category it is like this. You can also give an idea of that. So why it is like this, like why data is spread is below 20,000 and why data spread is very less after 25,000. So there will be a reason, like maybe the transactions happened in a bigger showrooms like furniture or any electronics. Distribution of amount based on the gender. As you can see, these are the distributions of the gender based. And I'm checking if there are any other things other than any classification things in the target column, but no rest. Like we can see one is 0 and one is 1. So I'm taking two data sets and I'm seeing the analysis based on these target data sets. So you can see I'm like I have written the insights from this. The number of transactions happened in the month of March and May. The fraudulent transactions are in most in grocery POS category. So we can give a heads up or we can have a flag where transactions are happening at this category. The number of transactions are more on Saturdays and Mondays usually. Customers are using credit cards more for gas transports category and very less customers using credit cards for traveling. So in gas stations also people tend to use credit cards and cards more often. Sorry. So this is the time distribution where fraudulent transactions happen on hourly basis. So there is this package. If you want to explore, you can explore and see the distance between longitudes and latitudes. So this is the function where I can use this. So I'm converting the columns to date time format. As I mentioned, we won't be getting same formats. And for modeling for modeling purpose, I'm dropping the unwanted columns. So it's not ideal to pass IDs or any unique numbers for the record to model. So it can't get anything, like it can't take any insight from them. Because when we are giving new test data or when we are giving unseen data, always the unique number will be different from what it has learned. So we are training model in a redundant way so that it will think it is not in my list, like what I have learned. It is not, it is out of my trends what I have learned. So there we may miss out the like metrics of the overall prediction. So here I'm mapping the categorical variable to numerical. And I'm creating dummy variables like aware of this. You know, so let's say I'm having gender column and I can map male to 1 and female to 0 or vice versa, whatever it is. So what if I'm having state column and I'm having all entire 20 states? What will be the mapping will be approach? So you can't sit and map 1 to 20. Okay, if it is 1 to 20, fine. So what if it is 80 or 90?
They separated by markers.
Sorry?
Markers.
So even then, if you want to separate it, you need to have an idea like what comes under north and what comes under south. And again, it's a manual thing to enter all 80 names or 90 names and categorizing in north, south and north. So what if there are 500 different entries, different categories? Let's talk about villages. So there are many across India. Even we don't know how many villages we'll be getting. So here we will be using this thing called as get dummies, where it will see the number of categories inside, number of different unique things inside a column, and it will create a column name of everything, and it will flag yes or no, 0 or 1 for everything. So yeah, it will increase the records, but it is in like computer understand language with zeros and ones. We can give it for modeling. So instead of saying category and these many categories, now I change this category into different columns, saying if the record is food category, 0 or 1. If not, if it is comes under gas transport, 0 or 1. So after like creating these categories, I can drop the original category. It's no point, like it is correlated anyway. So here I'm building a model. So I have tried with a couple of models, like to see what model is performing well with this model. And it is not always same for each model to do like this. Like we can always check. We need to always check which model is performing better with this data. It's not always the same that this model should perform better with this data. It depends on data. Each model can learn, and the output can vary. So here I tried multiple data sets, regression, XGBoost, decision trees, and all. And these are the metrics of each data, each model. You can see the train accuracy and test accuracy. And this is decision tree. And I also use this oversampling techniques, 3 oversampling techniques across all the models to see what model I can get. As it is an imbalanced data set. Yeah, these are the predictions on the test data set. So any doubts in this, or any doubts in this problem statement, or anything what I have talked? So as I mentioned, this is a highly imbalanced data set. You can see the records of is fraud and is not fraud. So usually this will be the case. It not every transaction will be fraudulent transaction, right? Any doubts?
Ask more, but we can ask you later on, like while going to other stages.
So the doubts before this session, till this session, if you have any things, if you want to know anything, if you want to ask, or if you are in confusion state, or if you really want to know what is happening in real life or whatever it is, based on my knowledge, I can answer.
Like, how will you define, like, how will you go for an algorithm that we have to take so particular model to build it?
Again, depends on the data. Within continuous data, regression is the first basic step we need to see. It's in classification. In classification things we need to start from every model. As I said, each model, like for each data, each model learns some data well. Again, it's always resets or trying part where we'll get an optimal result, where we'll get to know this is the best model.
It's not like we should only take one model. We can
Yeah, we should try it. We should try it. Yes.
Then we can
Then only we can get the conclusion. Yes. So it's all about the distribution of data. So if we are talking about decision trees and all, so in decision trees, which is always the class which is getting a new tree. If it is no, it is coming to a new tree. If it is yes, if it is going this side, and again when the next feature comes, based on that feature, again it is being classified. So the type of data is suitable for that. So when we are experimenting, we'll get to know how the model is taking the data and how it is performing.
Like we haven't learned about the classification. Can you please elaborate it?
What classification?
Classification of data. Depends.
Classification of data.
Assets.
Types of data sets you are asking. Yeah, there can be lot. One is JSON, which is in dictionary format. So we'll be having records. The most of these will be responses of an endpoint of an API. When you are calling an API, the response what it is catching will be stored in JSON. JSON L is nothing but JSON lines. So the multiple JSON records make a JSON L file. We need to iterate through that. We need to make changes based on the requirement of dataset, and we need to approach.
Where we can transform the JSON file data into
Using Python, it's not any hard code function. So Python is helpful for us in this thing, like when we are trying to iterate through records, or when we are trying to transform, or when we are trying to update. So just like I used this dictionary map to change male to zero, vice versa. So here I'm using dictionary, like the help of Python, only I'm achieving this. So it will make our work easier. Like when we need to iterate, we need to think of how it can be automated with that script. So it's not always 100 records or not 50 records to do it manually. We don't know the actual data. When our model is in production, where it is placed, when we are not monitoring it, we need to handle all those, right? When the real data is getting, when real things are getting to it, when it needs to give the score, and it needs to predict if it is true or false, it should be robust enough to read and give the record, and give the response. So in whatever the format, if we are getting the data, so when it is reaching the model, it should be in a format where the model directly can fit and give the response. So the middle area will be the automated thing, what we are doing with the Python.
so how the data comes into the data pipeline.
That data engineers will do with the help of tools, NiFi, etc.
Is there any scope like if we are doing SDA
Mhm.
and is there any scope that we can get into data engineering?
Like it's about in data engineering, it's about more number of tools.
More number of tools that you talk about.
There are number of tools, the number of steps.
Can you name some tools that are
One is NiFi, one is PySpark,
quite sparky?
one is Apache Hadoop, and all. These are big data things where the
Big data tools.
data pipelines will be created by the big data engineers and by. Any doubts?
Explain few models. I'll ask you have explain about the chats. How you make binding sets and such things. We're seeing that such a binding set.
So here you can see number of fraudulent transactions, non-fraudulent transactions on based on gender. So more number of transactions are done by females than males. Like they are the victims of these fraudulent transactions. See, this is a highly imbalanced data set. Even then, we can see the huge difference in the gender as well. And this is the age range what we are talking about. See, so most of the transactions happened in the age of like people who are in age between 40 to 50. So we can see the number is high. and there are very less. The age is 10 to 20, obviously. So most of them don't use any cards or any online transactions. So these are the different state codes where transactions are being happening, and you can see fraudulent transactions are happening in. I think this is Texas and this is New York.
So I still have some doubt like for balance check and imbalance check. Please describe it in a simpler way.
Yeah. So what you are seeing is an imbalanced data. I'm not saying it is not a genuine data set. So this is a genuine data set in modeling point of view. So what is the final goal of model? To predict if it is fraudulent or non-fraudulent. So what it learns is, so if these are the patterns, if the feature A is like this, if the feature B is like this, the feature C is like this, and so on, and what is out? If it is fraudulent or non-fraudulent. So if it is yes, it is learning the pattern. So when the column is having this, when the column B is having this, and ultimately the output, ultimately the result will be a fraudulent transaction. The same way, if we are not training the model with enough non-fraudulent transactions, how can it predict?
So the non-fraudulent data is not there, then it cannot predict, right?
So if you are not doing any pre-processing steps and if you are directly giving this data set what you are saying, it can't give the effective model. So here as I mentioned, smart oversampling techniques applies, and it will increase the number of non-fraudulent transactions based on the records what it is having internally. It will try to increase the data overall, and it will try to increase and try to match it. Like it's not always that it should be 50-50. It can be 55 45, it can be 60 and 40. Even then it is not imbalanced. You can see the graph, right? So it's very highly imbalanced. Like out of 12 lakhs, I guess we are having only 7,000 records are fraudulent transactions. So when we are directly feeding the data, it's impossible to machine to learn and identify and separate, differentiate. These are non fraudulent, these are fraudulent. So it needs like the more number of data you have, the more number of amount of data you are training to your model, the model gets robust. So in general, in production, how the cycle will be is like, let's say there is this lead scoring model what I have in my place. So when you are giving the test data, train data set and all, it just got trained and we are ready to predict the test. So what if my model performance is getting reduced? So what are the chances? So here the catch is like there is there will be a system, there will be a cycle where when the new data set is available, it is directly trained automatically. So let's say I have launched my released my product in January. So when I release the product in January, let's say the accuracy and all are like 75 to 80%. So over the period of time, when we are reaching September, October, it might end up giving results of 40 to 50%. What can happen here? So when I train my model, it is like 70 to 80. So what is the reason of this downfall? Anyone can think?
Balance.
No. So if it is imbalanced data set, when I'm launching my app, it will be inefficient. Like it is not. I won't be launching it out. So here, over the period of time, variables and the data might change.
Your data.
So this I have trained with the past data set, which it saw those trends and trying to predict based on that trends. So now over the period of time from January to September, I have a lot of data. I have seen many changes. So the trends changed here. So now what I will do is I'll be putting a cutoff of 3 to 4 months. Whenever I'm getting like enough data of 3 to 4 months, I'm pushing it back to training data. So I'm appending it. I'm not removing the old data. I'm appending it there. So then there will be a change. Like there, it might decrease or increase. We never know based on the trends of the data. So it should be like a continuous flow. So when you do this, when the new record comes, you can't see much difference. Like if we are having 70%, it won't directly fall to 20%. because it is learning trends continuous. So this is the standard thing what is following. Exactly. Yeah, training data will always be updated. It's like appended, like it is increasing, not replacing.
Extended like.
Yes. With the 40,000 data what we have earlier, now it became 80,000. The next it will become 120. Like it will be a continuous cycle for the model to get an improved result. So there is an ideal thing. What is like it's an ideal practice to be employed?
Where all this data is stored then, like
Database.
in a server.
Yeah, database and servers. Yeah, we clouds. Like we need to connect it remotely, and we need to extract the data and work them. We can't store bigger amount of data anywhere in our local. Right?
Yeah.
Retrieval speed also will be very slow. We can't retrieve fast. Anything you want to ask on this imbalance data or anything? So what can be the reason here of this kind of box plot here? So in generally, what does the box plot shows us? Like what it is example, like what is that box and what is the line? So what it is trying to explain us in general. What idea you will be getting by seeing box plot? And
Belongs to the group in this actually. What is defining that the more number of transactions under 20,000 is under the group. In 30,000 and those are out there because less number of transactions are
so what is IQR?
in the quartile.
So the box plot actually shows the IQR. So above in the above cell, if you can see, I have added these 25 quartile, 50, 75, 95, 99, and 100. You see how the data is distributed. So first 25% of data lies under 9.6. So like the spread of data, the distribution of data from 25 to 50, you can see there is a quick jump of 9 to 47. And at 75, it is 83. Again, it is doubled. And in 95, it is 196. And at till 99th percentile, it is in 500. Right? At 100th percentile, like you can see, it's a drastic jump of data if of the amount of the records. Like it is 500 and it is like 28,000. So if you can see like 97, 98, 99, then you can pinpoint like where like most of the data is making to look this box plot. Like the output of box plot depends on this, right? So what is contributing towards this for this output? So you can pinpoint that and you can see how many records are there for this transactions are making this happen. Just I mentioned, if the in the age, if we are having 3-digit number and if you are blindly doing the mean will be different. The same scenario, so you can see the 0.25% is 9 and the 100% is 28,000. So the mean will always be different. So this is the spread of data what it is showing, like where it is ideally lying. So where the most amount of data is lying in this box plot. It will be showing the mean upper 25, lower 25, and 0 and the 100, right? So it is a representation of the bar plot. So not always about the outlet, but the distribution and the data where it is lying actually in the spread of 0 to 100. So just like I mentioned in this, so 0.25 to 100. So this is the spread and this is denoted by this. It is representing this in this. So as it is not that big picture and it starts from 0 to 5,000, we can't see what is actually happening. So as you can also see, least value is 9 and the highest value is 28,000. So there is a huge spread. There is a huge difference in the spread of data across. So like I again differentiated based on the gender and again I distributed and see like what is happening. So as you can see in females, like which is non-fraud. So it is like in this distribution. So as you can see, the effect of what this, like the amount what it is lying in here is mostly in female transactions, like females who are having transactions. So this is the thing. So here you narrowed down the thing, right? So in the beginning, you just know somewhere in the data we are having these things. Now you got to know, okay, this data is there when the transactions are done by females. You had a one more filter in your data and you just narrowed it down. And I'll again you can see it's not a fraudulent, it's a non-fraudulent transaction. With this you can see it's a non-fraudulent transaction. Like most of the time it was like female who had these transactions. So I just created two new data sets based on the fraudulent and non-fraudulent, so that I can see properly, because it is highly imbalanced data set. If I am comparing it with the fraudulent data set, which is like completely vast, it is 2 to 3% on the entire data set, so I can't relate it. It's not a fair comparison as well. So if it is huge data set and if you are comparing it with, you can't come to a conclusion and you can't justify what you are trying to achieve. So here I just created two datasets based on this to understand what is happening in fraudulent transactions, because most of them are non-fraudulent. It's not a big deal to pinpoint if it is non-fraudulent. Yeah, these are the age range of fraud transactions. So if you see, most number of transactions are happening in 40 to 50 age. So when we directly saw the big picture, we don't know like when fraudulent transactions are happening. When we are comparing to non-fraudulent, these are very minute. So obviously it will be like very minute. It's not a big deal, but we never know in that minute number of transactions what amount they lost.
Here, basically, there are we have done fraud transactions or non-fraud transactions from important for.
No, I'm just saying in a spread of columns what I can, as I just mentioned, to put a filter to narrow down the things. I'm just started my approach based on gender, age, area, whatever it is. Like you can also narrow down based on the columns what you see and what where you can put a filter and where you can narrow down. So I can put a filter in age. I can put a filter in gender. I can put a filter in area maybe. If it is widely spread, it's not a optimal approach to put a spread, because again, if you are having a big picture of what is happening in the data, you can't pinpoint or you can narrow down. This is the place where fraudulent transactions are happening. Yeah, these are the few transactions on hourly basis. So I just extracted the time, only hour, like 1 to 24. So as you see, most of the transactions are happening in the odd hours, like 23, like which is midnight. So I just mentioned fraudulent transactions checkpoints can be flagged. We can flag it anywhere. So this is one more save where it's an odd timing. Not number of transactions happened. It happens at that time, right? It's not a regular working day. So we can see if the transactions are happening in odd time, and we can have a checkpoint that if any transaction is happening after 20, like 9 or 10, we can have a flag saying that this is an off timing. We are having transactions if you want to authorize or not. Here, the fraudulent transactions are shown in the red line. There you can see the distribution. So again, in this 20 to 25, as I mentioned, in the odd timings, the fraudulent transactions count is more. Yeah, these are general things what I want to understand from the data. So you can see the category and their value counts, like where more number of transactions are happening and where the number of transactions overall happening. So in here you can see like most number of transactions are happening in gas transfer, but fraudulent transactions are not that not more in gas transport. So you can narrow down one more step here. So even if the number of transactions are more, it doesn't mean that fraudulent transactions will be more. So in this, grocery is in somewhere around third place. So in fraudulent transactions, it is in first place. And you can see this gas transport, it is in last place. The number of fraudulent transactions happened in gas transport is very less, but overall it is higher. So, like, can you mention any some of the non-important columns to drop? As I mentioned, ID will be the unique number what to identify each record for each transaction. Just like that, what can be the other columns which are irrelevant for modeling? Any example or anything which comes in your mind? So always we'll be having data in raw form, like not clean. We'll be having each and every record, each and every column. So let's say we are having a column, we're having a data set, and in a column it is saying that the source of data what we are having. Let's say it is from an Facebook application where the advertisement is done, and we are extracting the data and information from it. In the column Facebook, it will be Facebook all over the rows. We can drop it. It is Facebook. We know we are training it for the Facebook source. So what is the point of giving Facebook? We are not having a spread of data across other platforms. So that is one more example. As I mentioned, ID is one more example. And if we are having date column and again column month separate, so no point of having date and month. So which is already involved here, is already included here. And there can be columns like this. What is the age of the client and what is the age till today?
Can calculate from the age of the client itself.
So we don't need two columns in this scenario. These are redundant for the model. So these are like this is one few more example. In such a way, like did you come across any? You can think of and give an example. Can be place also if you are having a data of particular area. If given state, it will be same throughout the data set because you are handling dealing the data set with the same state. It's no point of having again the same state. So here, as I mentioned, user age, again the age till date, and again month, hour, day, decent. So I already have all this in the date format. And again, there is this distance thing called as uh, transaction day, transaction time, and transaction distance. So it's not always the same. So it's irrelevant for modeling purpose. If you want to analyze, you can use it to say if in this place it is happening more, in this place it is less, but it is not relevant for creating an application and like feeding the data to the model. So here I'm just using this logic regression and I'm just taking the model shape and this is the evaluation metrics of model over training data sets, and this is the ROC curve. So where we are having an AUC of 79. So here, as I mentioned, I'm using this oversampling method for the data set, and again I'm using the same logic regression to fit the model. If you see, there is a difference in the area under the curve AUC. So here it is 0.93. When we haven't do oversampling, it was like 0.79 because the trends, the number of records, that the pattern of learning, the learning rate changed from that model to this model because we are oversampling the data and we are giving it more knowledge on the data, what different trends are happening in the data. So it can relate and it can separate the data and it can perform well. So this is the use, like this is the most important step when you are going to modeling actually. So imbalanced data is you can see the result, like it's like 70%, 79%, and it is like 93%. There is almost 13% jump. So this is one more technique of sampling technique, the same thing. Yeah, so I have performed the same with this, but in this sampling technique for this particular data, for this particular model, it is not the optimal when compared to the previous technique of oversample. So it's just like an research and just like an analysis, what you are when you can, from which model you can find the best output. You should not stick with one. So some might get good performance with this, some might get good performance with the other. As just I mentioned, so you can see there we are getting 90%, and before that we are getting 93%. So with this is another technique, oversampler technique, and here again there is a drop to 0.91. Previously it was 0.93. So then I tried using decision tree without any sampling. So you can see AUC has improved better than the model with oversampling technique, which means this model can learn this data well compared to the logic regression. So here it is like 95%. So let's just wanted to see if it is improved when I'm giving oversampled data. Yeah, it increased to 97. So in this way, we need to see the which performs well. It's a match like miss and trial and error. Yeah. So there is this thing called as different levels of parameters and different hyperparameter tuning of the model. So we are telling model to learn in this way. So we are tuning the model. So the way the model learns, we are tuning it and we are asking it to learn in this way. So here we are giving it as this is the parameters group, and when we are dealing with these decision trees, we know this is the depth of the decision tree, and it stops here. So here we are mentioning at what level it should stop. So this is the parameter grid what I'm trying to send it. So I'm trying to give 5, 7, 10, 20, and 30, which means at fifth step stop it, like stop at seventh step and 10th step. And again the minimum sample leaf, the leaf what we are getting, the number of samples it should take is also the difference. Like once I'm giving 5, then it's from 500. So we'll be having a multiplication of these things, like 5 is the depth, and with this depth these are the sample ones, and this is the depth, and we are having these samples. So overall, like totaling of 120 different fits will be performing based on the grid search CV hyperparameter tuning what I'm trying to give. So based on these 120 fits, we will be getting a best estimator, best fit, like what will be giving the best output. So out of all, this is the best perform. 99.8 is the accuracy. And again, not always 100% accuracy is the good thing, which means it is overperform.
100% is overperform.
Yeah, overfitting the training data, which means it is not trained well. It is trained well such that it can't predict the unseen, not seen records, the new records. So like when we are splitting it train and test, we are giving it as an unseen records, which we are testing if the model is performing well or not. So if we are giving the same records from the training data, obviously it will perform because it learned the exact pattern, exact record we are having it in the training data. So when the training data is like this, there is a chance of model being overfitting and end up being not getting the proper results. So the performance decreases when this overfitting happens.
So my question is that, in your view, like, what will be the best model, like, best accuracy, like, what will you consider the best accuracy?
So based on trials, let's say in a real scenario,
Okay, in a Thailand method, you got like around 90% is our best output in all the models.
okay.
So would you consider it as a
Yeah, like if that was the case, if let's say let's say I'm starting with logistic regression only for The simplest thing to start with the simple thing. So I started with the logistic regression. So where I got 85 or 86%. So I started moving to some other modeling techniques and some other like fine tuning techniques and all. So there will be a point where whatever you do, you can't get better output than this. So that is a saturation state. So with that data, you can achieve only this. If data is differs, if data differs, yeah, as you said, it might change. So with that data, after all research, like we'll be getting a conclusion, we'll be seeing all the trends, we'll be seeing all the results, and we'll be stuck at a point where it is not moving. We might end up getting the same again and again. So no point of checking the all algorithms. So if the first algorithm is performing the same and giving the same output, if the 10th algorithm is same and giving the same output, you can choose the first one. So it should not be complicated.
Okay, we'll choose the first one.
Yes. No need of complication. So this is one more sampling technique, and again I performed this. So here, as I mentioned, you can see the recall. So the recall for training data set is 99% because most of the data what we have is true class and false class is very less. So recall deals with the false class. So here you can see it is not that great because we are having an imbalanced data set. So here this is the situation. And this is one more model XGBoost. So I use all the techniques in XGBoost, like the same adaptation technique for oversampling. Yeah, and this is the evaluation metrics of the model. So here I'm getting recall of 95%, if you see. So which means this model learns this data and can predict these false things correct comparatively. Comparatively, it's not always the best, but comparatively in this notebook, in this thing throughout this, so this is the best in recall and accuracy and everything. So this is the best suitable model here. Yeah, this is a test data set, and these are the predictions what I have. Like these are the transformations what I have done with the training data set. So if you are having trained data set in one format and if you are having records in other format, it can't fit. It will throw an error saying that I am not aware of this model. This thing to the like name error actually directly because it is not sure how to deal with that new record. So whenever you are getting the test data or when you are getting the live data, it should be pre-processed before sending to the model and fitting.
Yeah, coming to like that, I got a question. We have like we are giving a live connection to the data to get into the model. So like how it can take it up, like the data can be mistyped there.
So when you are in a production thing, so when you are having a data set, it won't directly go to the model. So pre-processing steps, what we have done with the training data set, let's say it might be mapping or binning. So if my column is having for gender, if I'm having 0 and 1, which is numerical, if I'm passing a string where female and male, how will it classify and how will it learn? Like how will it display? Like the pattern what it saw is a numerical, so it can't take it, right? So pre-processing step and mapping should be done before we are fitting the model. So the same data type of data should be fitted.
So like I mean, we have this live connections and take it from the local compressor. Like we download the data and take to the visualization, right? So while doing that, if we give a live connection to the data set, the data should be in that format before processing.
For visualization, you're saying, or modeling?
Visualization.
Visualization you can do without transformation, right?
Without transformation.
You can do. Yeah, it will be categorical. So whatever graphs which are suitable for categorical, you will be choosing and you will be doing the analysis. It's not needed to transform it.
Transform. There is no need of
No need of transformation. So for model fitting, it needs to have the exact thing what it had learned. So if you are giving, let's say the model is trained on some weather data sets. The data what you are getting is financial data set. So it can't identify, it can't predict. Yeah. So similar way, when what you are training, it should match and it should be transformed in such a way so that it can identify patterns and give the result. So the learning model, like it gave the predictions when we are testing, as based on this learning, right? These patterns. So if the pattern is changing, if the variables are changing, it can't identify, and can't relate, and it can't provide the answer. So that's why, like, when here the cleaning part comes, like if it is very really
So
clean,
if you are really not training the data means training the model means we need to do all this stuff before. Okay.
yes. So after this cleaning and after this EDA, after coming to conclusion that we can, this is the final data. Like out of all the bigger data, what I have raw data. So this is the piece of data which is used, which can be used for training or which can be used for build model. Then only you'll be getting an optimal results. So without analyzing, we can't directly put it. So in here cleaning, as I mentioned, there can be any changes, like not only null, not only missing values. So there we can have this scenario. For example, we are having only two columns. First column is like ID, unique ID of transaction. In second column, you might have a JSON record. JSON record holding entire information of a customer, name, age, time, amount, etc. You need to load it, like you need to unload it into CSV or whatever format you want to learn. Then you need to perform the thing.
Correct.
So why we are getting it in such a way that, so that is the final thing what we are, like I just mentioned, we are getting an unclean raw data. So this is one more form of raw data. And again, in that JSON also there might be cases where few fields will be missing. It's not directly a single shot transformation to transform it into CSV. We need to handle all these and we need to transform. So it may be a case where you are transforming it into CSV. It can be 100 or 200 columns. It's just a record. It's just a event of, like, captured event from the response of what you are getting from the client. So there, the thing is to capture that. Our thing is to clean and prepare the data. So the things what we learned comes into place. Like we might be dealing with strings, we might be dealing with category variables, we might be dealing with integers and all. So suitable functions, suitable things we need to apply based on the data set. We need to transform. We need to apply, prepare a final data set where which can be used for next step. So any doubts in this notebook what I have shown? Notes?
I've not been through all of these things like modern day.
So okay, in EDA, if you have any doubts.
Yeah, we just went to my first currency, but that's yeah. By that we can visualize.
Yes, yes. So what difficulties you are facing when you are performing EDA? Not only visualizing, generally understanding data or reading data. What are the things you felt are difficult or you are feeling that a challenging thing?
Uh, we are not able to visualize data basing on the domain. Yeah.
It's like depends on the data type. You need to understand what need to be done. As I mentioned, what you want to see from the visualization. What it's given 4 columns. What you want to show, what insight you want to derive from those 4 columns. Take any 2 columns, like what you want to show. So if you are showing, let's say these are the total number of transactions or records. These are in these 4 categories. This is the top, this is the least. Yeah, that's an insight. Like you are saying, you are learning. So before that graph, you don't know that which category is more, which category is less. So by that graph only you got to know it. So based on the thing what you want or what you want to show, just you can approach based on the data type, category or numerical or continuous variable. So based on that you can see.
What is your role about, like what is your domain in your so
I'm a machine learning engineer.
it falls like are you taking up all like
So okay, I mean, like let's explain. So when I joined here, I was data analyst.
okay.
So I dealt with the data cleaning part, what you are talking, data mapping, some manual thing and automation thing, whatever it is. So after that, I worked in different projects where machine learning algorithms. I have built machine learning algorithms.
Tell me about your data analyst experience. Like, what tools have you been explored?
The
Like, we
common,
have different tools like Snowflake, and we have this Tableau, Power BI, and other tools.
so based on the client, like we got data from their server, which is Snowflake. So we need to connect it through Python packages. We need to extract the data. So the data we need to map it with the Excel sheet what they have provided. As I just said, to have a data confidentiality, they can't reveal the names directly. If there is any data theft, if it is in coded format, he can't do anything. He can't deal with it. So when it is in their server and within in our server, we can take the data and we can map it and we can do the analysis of what is missing, what is not missing, what we can achieve, what are the useful features overall in that 600 columns. After mapping, we got a conclusion. With the mapping part and all, again, is dealing with the Python scripts. So when we are creating dictionaries or we are creating any list or anything based on the Excel sheet, and we are creating functions where it can map the particular column and give the final data. So after that, the normal data analysis part, sometimes in Power BI, sometimes in Jupyter Notebook. Depends on the situation, depends on the requirement. Yeah, depends on the requirement, depends on the situation. So there are a few columns which are very huge, we can't see in Power BI. So we are left with Jupyter, like Python. So that can be the situation. So based on that, we just slowly drop the columns which are irrelevant, which are repeated, which are unique numbers, which are unique transaction ID, user ID. Based on that, we remove that. So that is the approach where that is a full-fledged approach. And finally, we got 40 columns which are cleaned, which can be used for modeling.
Were you responsibility limited? Like, what were you responsibility limited to, or were you beyond that limits? Were you responsibility limited to only data visualization and
No,
clean,
I have done this modeling part as well.
modeling products in
Yes.
the data?
Yes.
Okay. So, okay.
So irrespective to my role, I worked in all cross functionalities.
Cross functionality.
Depends on the project and depends on the requirement. So I also was in a team where we developed demand forecasting application for e-commerce website in a partnership with Walmart. So we have launched the application in e-commerce website. So where user can come and give the details of the product and see the inventory, like he should restock it or he should remove the stock based on the patterns what he's having in the data for the future. So there was a complete setup where he can give where the user who is logging into e-commerce, he can directly have his own profile. With this profile, what are the inventory, what are the things he had, he can directly import them. And we can see the predictions there. Based on that, you can take a call. So that is end-to-end demand forecasting application where cleaning data, preparing data, transforming data, inputting data, and building a model, deploying the model to the endpoint customer. So that is the software endpoint team. This is my part.
As part of a data analyst, you should also be working together with business analyst and data scientists, right?
Yes.
And data engineers, right? So what will be the impact of working under them, working with them, not under working with them?
So when you are talking to data engineers, you need to be clear like what kind of data you want. Like is the data is transformed correctly. So their end goal is to scrape the data, like get the data from different locations, different databases, different vendors, whatever it is, structured, unstructured, whatever the format is. So to generate that different types of data into our database, which is having a similar, like only singular, like we can't store it in different formats. If we are having any database Postgres or anything. So in Postgres, we can't have unstructured data.
Okay.
Yeah, so they transform that into a structured data set where it can come and settle in R table. So as I mentioned, it can be single record with JSON, but it is in table ultimately. So there we need to work, and then we need to give the data to data science team where they do experiments on this. So when with them, with the business analyst while you're talking, so they'll get to know the requirement from the client. So though the clients never say, I want this distribution plot or not. I want this application with these things. That's it. So they are not technically strong, right?
Yeah.
So they say the requirement, they say the problem statement. Yeah, exactly. They say the problem statement. So this is my company. I'm having this thing. So as I mentioned, this lead scoring project, the main agenda of this is this. So they're having a daily customer call thing. So they're having some 100 employees who calls to the persons who are coming to their websites and giving numbers and asking if they are really interested in their real estate product. So on an average day, if they are getting 4,000 to 5,000 traffic on their website, which means they are having 4,000 to 5,000 mobile numbers. So we don't know who are the potential customers there. So instead of calling 4,000 to 5,000 members, once we are getting the data, after giving it to the like model, it will show how potential the customer is. So if it is flagging it as yes, instead of calling 4,000, you can like call twice or thrice to the customers who are really potential. So in that case, no need of having 100 members. You can reduce the tele customer to the 50 members, and you can on a day if they can perform 1,000 calls. If after the model is done, out of 4,000, it is picking like only 1,000 are the potential customers who are really willing to buy. So it can be achieved in one day. Instead of if we are calling, if they have to make call and make like do follow up for the each and every customer for 4,000, it takes 4 days. Now it is dropped down to 1,000, which can be achieved in a one day. So which can be cost efficiency, can cut off the employees, and we can have the time limit. We can be more efficient. So here, this is a requirement from the business analyst. Like what am I getting? What my business is benefiting? So how can this benefit my business? Why should I pay you, and what am I getting? So this is the final agenda. Like this is the thing, we are getting leads. We need to have a lead score where we need to call and see if it is a potential customer or not instead of wasting time. So this is that thing, and we'll be having asking for the data. They will be giving the data what they have collected past years. So then we need to build and develop and see, and we need to like put a model in a production where a new customer or when new record generates, it has to go through the model and shows yeah if he is potential or not. If not, don't call. That's so it will be beneficial for them to not to waste time. So this is the entire cycle of a normal project. So like I can say it in two statements, but reality it will take months.
Backside, if you have any doubt, ask to the sir right now.
Yeah, you can ask.
Yeah, I do have a doubt in a very general perspective. Like we write almost 126 lines of code to predict that what is the final outcome we get that the female are getting more attacked and the age group is 40 and and the most of things are happening in groceries. That's the final output for which we write 136 lines of code. But we don't know what might be the reasons for groceries. What I mean, these are just basic things.
So here you are analyzing to pinpoint it. Once you know this is the place where people are getting hit, you can always go like you can give a heads up to them, or maybe there is a fault in mission, or maybe there is a fault like the area or the place, or what do you say, like there the fraudulent is happening. So let's say we drop down to one store particular, for suppose in the grocery store, after all the filtrations, after all the things, so now we got to know these grocery stores are having more hit. So the one more layer, which area of grocery stores are getting more hit? Again, you got an arrow down. So if you can pinpoint two or three locations, like as a bank perspective or the fraudulent transactions, you can visit or you can communicate with them and you can explain this is the situation, and you can have a flag there. Or if any bigger transactions are happening, to cross verify or to take a call and pass the transaction or not. So in this way, instead of putting the flags everywhere with every transaction, they can narrow down and put the flags with the particular transaction, right? As I just mentioned, instead of calling 4,000 leads, it's better to call 1,000 leads. Instead of like cross verifying entire transactions, we can we can cross check only few transactions. It's impossible to like track every transaction. We are paying through Google or anything. It is impossible. Like this amount is going to detect. Are you authorizing? Are you authorizing? It is not fair tool to do every transaction.
But we don't get the exact reason why it's happening. We are just pinpointing like.
Yeah, we are giving the analysis report. Here it is happening. Why it's not our case according to the data? Yes. So here, yeah, that's what the main concern, like the main analysis, what we are doing is we are narrow downing this thing based on our data, what we have. Can we really say why it is happening? Let's say if you have the data, relevant data, so that you can pinpoint. This is the situation. Let's say in that grocery store only, there are three mode of transactions. One is cash, one is scanning, and one is some online transaction. Let's say online transaction. So if we have these things, and if you can see in online transactions, there are more fraudulent things happen. So now you can pinpoint that their servers have been hacked. People who are coming to the store and doing transactions there with that for their shop or whatever it is, their servers have been. With this, we are not having right now. We don't have this information to pinpoint. So in this information, we can give this is the situation where more transactions are happening, which are fraud.
I said if already have download from that side. Anything you can ask. Right now, you can have all the items. There is a
Sorry, free.
Please.
So yeah, okay. Depends on these like because of this generative AI, you need to learn. You need to be you need to aware of what is happening in the market. So it just ML has been upgraded a level. So you also need to upgrade. If you are not upgrading, you will be standing there. Then you need to upgrade and catch it. Saying something?
We need to always upskill ourselves. Being a data or being a data scientist, we need to always upskill ourselves.
So there are many tools, many functions which can improve our analysis part also. So there are few packages where it's called as auto EDA. So most of the EDA part is done by the package. So if it is handling, like why are we? You need to see what it is doing, what we are doing more than that. You should be aware.
We have not gone all through the data.
You should. Okay. So like you can ask the doubts which are not with this task.
The tools, models, tools, they can impact us.
Yeah, why not? So if you know something is working fine with your data, or if you know something can solve your situation, if you know how to use, will you use it or not? That's it. Yeah, thank you. If you have any doubts, you can ask. You can go. मैंने क्या वीरू से बात कर ली वीरू से बात कर वीरू खुद मैंने पर नाम ना वीरू का
So as of now, it is done. Okay. Sorry. And you can find this data set and this problem statement in your dashboard. Okay. You can go to your dashboard.
Yeah.
Okay. Go to dashboard. Under the dashboard, you can see the schedule block. Okay. Go to schedule block. And here you can see data science hackathon. Okay. Here you can see the data science hackathon. So open it. You can see the problem statements here. Okay. So data cleaning and this temporal analysis and next merchant analysis and everything you can see geographical analysis and advanced visualization correlation, right? Who are done with this Python and Excel or Power BI. So those guys can do this one. So remaining people just watch the data. Okay. So this data set you can find from resources. Step 2. Okay. Right side you have resources. So go to resources. Here you have train data and test data. Okay, so the train data is 2 lakh 1 lakh 10,000 rows scan, and test data is 80,000 rows. Okay, so this is big data actually. So I reduced into this 1 lakh and 80,000. So earlier it is 10 lakh plus rows. Okay, around 15 lakhs to 20 lakhs rows. Okay, that is a huge data. So it is not possible to open through Excel. Okay, so Excel allows only 10 lakh records only. So 10 lakh something records only it allows. So it is more than 10 lakhs. So that's why I reduced this one. So it is very big data. So you can download that 1 lakh records and 80,000 records, and you can load into your Python or Power BI. So who are good with Power BI, you can do with Power BI, or else you can do with Excel even. Okay, in Excel also you can do your visualization and your EDA part and data extraction. Everything is possible with Excel. Excel is a very powerful tool, right? So as well as Power BI and Python. Okay, right. So after done, after the completing your analysis and visualization part and your modeling part, then go to the submission block and submit your .ipynb file or .pbix file or .xlsx file. Okay, so any file format it may be. So you submit your file here. Okay, so first go to introduction, see the data set, this question task, and go to resources, download the data set, and first look at the data set, which type of data it is. Is that CSV format, or is that Excel format, or is that any another format? Okay, first go to properties and check which format it is, right? Next, go to your module, any module it may be, then follow your syntax, right? So if that is a CSV format, so pt.read underscore CSV, or if that is a Excel format, underscore Excel. And if you are using Power BI, go to get data, go to file, and select Excel or select CSV, anything. Okay, same as well for Excel also. Go to get data and select Excel or select CSV. Okay, next after completing your analysis, submit here. That's it. Okay, so follow these are all things, and already he shown that solution also. So how to solve these are all things. So import which things you may want, pandas and matplotlib, and these are all things, and go with analysis. So basic plots only used, right? So count plot and bar plot. Okay, and some box plot. Everyone knows this box plot, how it is working, and count plot, how is it working. And next you have a scatter plot. So how it is working, how many zeros and ones here. Plot yes, no. 0, 1 means yes, no, right? So some Seaborn box plot, sorry, Seaborn bar plot. Okay, so more colors you will get. Compare with matplotlib bar plot. See, this is with matplotlib. Only single colors you will get. This is 2-dimensional chart, right? And coming to Seaborn, so three-dimensional, and you will get more colors, right? So like this things. You this is the combination of two charts, this plot and this one. So this plot means distribution you will get, and as well as KDE, kernel density estimator, you will get. Okay, so when I'm using hue, I will get more colors. Okay, and this is data science one. So who are completed data science part, so those guys can complete these things. Okay, so using machine learning module, this models, they can complete those things, predicting the future, and based on these features, so he's doing fraud or not. Okay, so like that they can compare. So up to where you completed, suppose you are done with Python. Okay, you can do this project with Python. Okay, you done with Excel, you can do this project with Python and Excel, the combination. Okay, suppose you're done with Power BI, you can do with Excel and as well as Power BI and as well as Python. Okay, so you are done with data science, suppose machine learning, you can complete your model building also. Okay, and that's it. Okay, these things you can do. Fine, is it clear online? Yeah.
Yes,
We are
sir.
the fresh batch actually. So we haven't been till there. So we are just
Yeah, you can sit with your seniors. Okay, so who completed their Python part and Excel part. Okay, you can sit with them and how they are doing. Just observe. Okay, give a try. Suppose you have your own knowledge, you can share with them, and how they are doing, they can explain.
How can you differentiate it best?
Okay. So these four and that last four. Okay, so those are all your seniors and Basha also. Okay, so the remaining are juniors only. So yeah, just they're fresh. Okay, anyway, 71, 72 batch also they done with NumPy and they done with pandas, right? Okay, so this is the way only pandas. The first one is pandas, importing pandas. Okay, so how you are doing your analysis, that is very important. Okay, so you can sit with your seniors and how they are doing, just observe that. Clear? Yeah, fine. So you can download these things and you can complete your this one. Fine. So if you have any doubts, drop a message. Okay, fine. Online it's clear, Atharva.
Yes, sir, it's clear.
Yeah, fine, very good. And remaining Devjyoti, Laharika, Tariq.
Yes, sir.
Yeah, fine. Okay, please complete this one and upload it. Okay, then we know how much good with your how much you are good with EDA, and these are all things. Fine. Yeah. Bye, guys.
Thank you, sir.
Yeah, thanks, man.
Thanks, sir.
Yeah, thanks.
Thank you, sir.
Yeah, thanks, Tarva.